Visit us at Eduvvo. Thank you for calling Eduvvo.
In this video, we'll discover how width and height properties allow us to specify the size of elements, and how overflow properties let us define what happens when content overflows its containing box. Let's go. We'll start things off with a simple HTML file containing an example navigation and a div with nested paragraphs. We'll be creating our styles in styles.css, where I've already created a few CSS rules just to get things started. And we can see what this is looking like in the browser. As I mentioned in the previous video, we can override the default display settings of an element with the display property. The most fundamental and most common types of display values are none, block, inline, and inline block. For example, if we give our nav element a display property with a value none, when we refresh, we see that the nav's display is now turned off. So it no longer takes up any space on the page, and the page displays as if the nav element wasn't there. The value block is the default value for block elements. It makes them generate a block element box with a line before and after it. Anchor elements, by default, are displayed inline. So let's see what happens if we add a display property to the links and give it the value block. When we refresh the page, we can see that the links in the nav are now being displayed as block elements. Each link is on its own line with a line before and after it. The inline value places the link back within the flow of the line. So now they're back to how they were previously displaying, because anchor elements by default are displayed inline. So we can go ahead and remove the inline value. However, if we needed to apply a width, height, or a top and bottom margin to the link, we can't just yet. When we refresh the page, we'll see that nothing happens just yet. In order for the width and margins to display while they're in line, we'll need to change the display value to inline block. So we'll go ahead and add a display property with the value inline block. The value inline block generates a box that's a block element flowed with surrounding content as if it were an inline element. So now when we refresh, we can see the top and bottom margins and width applied to our links. Keep in mind that negative top and bottom margins cannot be applied to inline block elements. Another property we can use to hide certain elements is the visibility property. A visibility value of hidden works similar to display none, except that it still affects the layout as if the element was there. It just makes it invisible or fully transparent, still taking up the available space. So for example, in our nav rule, if we add a visibility property and give it the value hidden, we'll refresh and notice how this time the page renders as if the nav was still there. If for some reason we needed to override the value hidden, well, we can use the value visible, but that's the default value, so we can go ahead and remove it. By default, a box's width and height is as wide or as tall as the content it holds, but we can set our own dimensions using the width and height properties. Both width and height can accept length units such as pixels, ems, or percentages in their values. Using a percentage for the width makes the size of the box relative to the size of its containing box. M values make the size of the box relative to the current font size. So here, a value of 20em is equal to 352 pixels. Pixels are still commonly used because, as we've learned in previous videos, they allow precise control over the size of the box. When defining height values in percentages, it's important to understand that you cannot give an element a height that completely fills its parent element, unless the parent is given an explicit height. So, for example, if we give our div a height of 100%, when we refresh the page, notice that the div's height does not expand to fill the page as we might expect. Well, we already know that HTML elements are pretty much boxes stacked next to or inside each other. And when we set the height of the div to 100%, what we're doing is telling it to stretch to the full height of the box that it's in. In the HTML, we can see that the divs containing box is the body element. So for the height to work like we want it to, we'll need to apply a height of 100% to the body element. When we refresh the browser, we still see that the div's height hasn't increased to fill the page. Well, that's because now we need to set the height for the body's containing box, which is the HTML element. So in our style sheet, if we select the HTML element and give it a height of 100%, we'll refresh the browser, and now we see the div take up 100% of the page's height. Keep in mind that when a width or height is defined, we're not exactly defining the entire area taken up by the content, padding, and borders. We're actually just defining the content area itself. So the area right in the middle. To calculate the full width and height of the box, we must also add the padding and borders applied to the box area. The calculations for width are padding left and padding right, plus border left and border right. So currently, the total space this div takes up is actually 560 pixels. 500 for the content area, 20 pixels of padding on each side, a total of 40, and 20 pixels total for the border width, which is 10 pixels on each side. Like for width, the calculations for height are padding top and padding bottom plus border top and border bottom. What we've covered here is the traditional box model of CSS 2.1, called the content box model. It's important to understand how it works because it can get a little inconvenient and tricky to work with at times. I'll show you what I mean. So let's go ahead and increase the left and right padding of our div to 50 pixels on each side. When we refresh, we see that the width of our div increases by 60 pixels because we've applied an additional 30 pixels of padding on each side. So now our div is actually 620 pixels wide. This can actually create some issues, especially when building layouts. So what if we need the div to be exactly the width we specified, 500 pixels? Well, we could do a little bit of math and maybe subtract the border width and padding from the specified width. An easier way to solve this is with a new CSS3 feature that does this for you, called box sizing. With the box sizing property, we can alter the way width and height are calculated. The value border box forces the padding and borders into the width and height instead of expanding it. So when we'll refresh, we'll see that as a result, the final width of the rendered box is the actual 500 pixel width we declared. As you can see, box sizing makes it much easier to define flexible widths where we also need padding and borders. So it's one less thing to worry about when laying out our pages. Box sizing is pretty well supported as all major browsers support it, except IE 7. Currently, Firefox is the only browser that still needs a vendor prefix. So let's make sure to also include the MOSD prefix declaration. We can also limit the width and height of our boxes. With the min width property, we can constrain the width of a box to a minimum value. Min width specifies the smallest size the box can be displayed when the browser is narrow. So if we give our div a min width value of 320 pixels, when we refresh the browser, the div will not be narrower than 320 pixels when the browser window is reduced in width. Max width indicates the maximum width a box can be stretched when the browser window is wide. So if we apply a max width property with a value of 700 pixels, we'll see that a value of 700 pixels will not allow the width to be wider than 700 pixels, no matter how wide the browser window gets. We can use max width to make sure lines of text do not appear too wide, and min width to make sure they're not too narrow. We can also constrain the height of a box with a min and max height value. For example, if we apply a min height value of 480 pixels, the div will never be smaller than 480 pixels, but it will be allowed to grow normally if the content exceeds the minimum height set. In our style sheet, if we change the min value to max and make the max height 200 pixels, when we refresh, we'll see that with a max height of 200 pixels, the div will never be taller than 200 pixels, even if the height property is set to something larger. As you can see here, if a box is not big enough to hold the content, the text overflows. Well, we can handle overflowing text with the Overflow property. The Overflow property accepts the values visible, hidden, scroll, and auto. With the visible value, the content is not clipped and still rendered outside the containing box. Visible is the default value. We typically would not use this value unless we need to override a value previously declared. In our style sheet, let's go ahead and reduce the max width to something smaller so we can clearly see how overflow works. So we'll change it to 400 pixels. Back in our overflow property, the value hidden hides or clips any content that extends beyond the containing box, as you can see here. This is sometimes good to use with dynamic content if you're worried that the text might break your layout. But as you can see, we cannot see any of the content beyond the clipped area. The value scroll is the same as hidden, except that it provides a scroll bar inside the box that lets us scroll through the content. Depending on the browser, scroll gives us both vertical and horizontal scroll bars. However, if we don't need both the vertical and horizontal scroll bars, we can use the value auto, which, depending on the browser, provides scroll bars only when they're needed. As we just learned, when developing layouts, it's important to have a fundamental understanding of the CSS box model and how the various properties interact with each other. Coming up in the next video, we'll go over common layout methods and positioning schemes using the flow property.